Hi all, welcome to Cambagilam Field Chemistry. Last class we have discussed 10 questions from the previous year question paper of HSST Chemistry Junior. In this video we are going to discuss another 10 questions from the same question paper. And before that, last video I have made one mistake in question number 1. That is, I mentioned that the abundance ratio is 1:3, but it's wrong. 75% of chlorine is chlorine 35 and 25% only 37. So the ratio will be 3:1. In that, there I mentioned 1:3. That's wrong. Cl35 is we are considering as 3 and Cl37 as 1. Remaining thing similar to that. You can you just change that thing. In that video I have pinned that comment, so in coming videos also you just check the comment box where I will, if I made any mistake, I will pin the correct answer. So you just check the comment box also. Answer is same B, but what I have taken is just reversed. Cl35 is 75% and Cl37 is only 25%. So ratio is 3:1 that you have to correct. Now we can move on to our first question in this video, that is 11th question. The indicator used in the Morse method is fluorescein, eosin, peroid, chromate. And Morse method, it uses chromate ion as indicator for agendometric determination of bromide, chloride, cyanide ions. And here you can see we can take one chloride, that is sodium chloride. When it is reacting with silver nitrate, we will get silver chloride and sodium nitrate. Endpoint means in this method, endpoint means the excess silver that react with the indicator to precipitate as red silver chromate. That is the endpoint. That is, silver will be the silver nitrate will be yellow in color. When it is reactive with the indicator, it will form a red color of silver chromate. That is the endpoint, and it is performed at the pH of 8. And its application is determination of chloride ion in neutral or unbuffered solution. So the indicator used in this method is Morse method is chromate. Option D is the correct answer. Question number 12. Number of bridging carbonyl in IR4CO 12 times at lower temperature is. So we have to know the structure. This is the structure of IR4CO12. In metal carbonyl, you just go through some of the structures like Fe2CO12, Fe2CO9, Fe3CO12, like that. Some basic structures, some common compounds, you just go through the structures. Otherwise you can calculate the metal-metal bond and later you arrange. Like that also you can do, but it's easy to understand, or it's very easy to remember the structures. So you just go through the structures. I will do some one video on based on this metal carbonates, some basic structure and its metal, how to find out the metal-metal bond. Later I will do one video. Okay, now you can see that here no bridging carbonyl. This is known as terminal carbonyl, and here no bridging carbonyl. So the answer is 0. Here total metal-metal bond is 1, 2, 3, 4, 5 and 6. 6 metal-metal bond is there. How to calculate metal-metal bond, that I will discuss later. Question number 13. The term symbol for boron is. The general formula of a term symbol is 2s plus 1 xj. Now boron have an electronic configuration 1s2 2s2 2p1. We have to consider the outer electronic configuration only, that is p1. Now we have to find out the s value. So spin value is only one electron is there, so it is 1/2, and then 2s plus 1 will be 2 into 1, 1/2 plus 1, that is 2. L value means -1, modulus of -1, that is 1. If L value is 0, that is representing S or S term. L equal to 1 means P, L equal to 2 means D, L equal to 3 means F. Okay, how we are taking this as minus 1? Here this is p orbital, minus 1, 0, plus 1, like that we have to take, and d orbital when considering minus 2, minus 1, 0, plus 1, plus 2, like that you have to take. So here the modulus of L value is 1, so it represents p term. The term is p, and we got the value 2s plus 1 as 2. So we got two values, 2s plus 1 also we got, and the x also we got. Now we have to find out the j. J means it representing L plus 1, L plus s to L minus s. So here s value is 1 by 2, L value is 1, so 1 plus 1 by 2 to 1 minus 1 by 2, that is 3 by 2 and 1 by 2. There is two j values, 3 by 2 and 1 by 2. So the terms are 2p 3 by 2, 2p 1 by 2. So here 3p 3 by 2, that is wrong. 2p 3 by 2, that is the right answer. Here 1, the 2s plus 1 value is not 1. Here 2p 5 by 2, so there is no j value for like 5 by 2. The answer is 2p 3 by 2, and the ground state value will be 2p 1 by 2, because this is less than half filled. When less than half filled is there, then lower j value will be the ground state. So the answer is option B. Next question. The commutator S d by dx, the value is minus 1, 1, 0, 2. How we can do this question? This commutator we are writing as this simply this have no meaning, so we have to apply some function in that. S d by dx of fx means x into d by dx of fx minus d by dx of x into fx. That is the expanded form of this commutator. Then we have to solve this. Then this x into d by dx of fx minus here it is like a d by dx of uv, that means u into dv by dx plus v into du by dx. So here u as in place of u we have x, and in place of v we have fx. So x into d by dx of fx minus f of x into d by dx of x. While solving this, we can cut these two values, then we are getting minus fx into 1. So now we can remove this function to get the correct answer. X d by dx equal to minus 1, and also remember if the terms are interchanged, that like d by dx and x, the value will be 1. So don't forget this. It's simple to do this exercise. You can just go through that. I have made one video on quantum mechanics, that also you just check. This comes under operator. Like this, lot of some tricks are there to solve these things, that I will explain in some videos. So the value is x d by dx equal to minus 1 and d by dx x equal to 1. Now our correct answer is option A. Next question. Complexes formed by the lanthanides with hindered beta diketones can be separated by option A gel permeation chromatography, option B gas chromatography, option C gel filtration chromatography, option D ion exchange chromatography. Here lanthanide forms some complexes with a beta diketonates, and it can be separated by any of the which chromatographic method is best for the separation. That is the question. Now we have to understand what is meant by all this chromatography and what is the peculiarity of all this chromatography. First, gel permeation chromatography. It's a type of size exclusion chromatography that separate analyze on the basis of size, typically for organic solvents. This technique is used for the analysis of polymers. And gas chromatography is used to separate and analyze compound that can be vaporized without any decomposition. And this gas chromatography can be applied in the analysis of lanthanides as mixed ligand complexes. There is lot of research papers are based on this. Then gel filtration means it's also a type of size exclusion chromatography. Here molecules are based on size. It's also known as molecular sieve chromatography. Gel filtration chromatography also known as molecular sieve chromatography, and the separation is based in the differing ability of the molecule to enter the pores of the gel filtration medium, and it can be separate compounds like protein, polysaccharide, nucleic acid when in aqueous solution. And ion exchange chromatography means it separates ions and polar molecules based on their affinity to the ion exchanger. This ion exchanger are of two types: cation exchange chromatography and anion exchange chromatography. And it's generally used to separate molecules like protein, amino acid, etc. And normally for lanthanide analysis, the stationary phase we are using as a low capacity cation exchange resin with the aqueous solution of complexing agent as mobile phase. So here the correct answer is we can tell ion exchange chromatography, because commonly for lanthanide separation we are using ion exchange chromatography, but there is a lot of study for lanthanide separation gas chromatography also used. So both the answers are correct, but in PSC answer key, the correct answer they have given is option B, gas chromatography. So you can also comment on this based on this question, which one is more suitable, or which one is the right answer, that you can check. I feel both the answers are right. Next question, structure of C2B9H12 minus is closo, arachno, nido, hypo. This is a carborane. Carborane means carbon and boron is there in the vertices. So carbon we can write as BH we can write. One method is you can directly give this, you can replace this carbon with a BH and minus with H, and you can solve it. That is the best thing. I think that is a little bit comfortable. So you can replace this carbon as BH and minus as H, then we will get B11H50. And when it is BnHN plus 2, it's closo. BnHN plus 4, it is nido. BnHN plus 6, it is arachno. And BnHN plus 8, it is hypo. Here you can see 11 and 15, it is representing BnHN plus 4. So the answer is nido. Option C, nido. Next question, ground state term symbol for of cobalt in COF6 3-. We already did one question related to term symbol. So here cobalt have an electronic configuration of D7S2, and cobalt 3+ means D6. This but fluorine have a minus charge, so cobalt effective charge for cobalt is 3+. So cobalt 3+ is D6. This fluorine is a weak ligand, so it will form a high spin complex. So cobalt 3+ we can write as D6. So the electronic configuration will be like this. And now we have S. S means spin quantum number, that is 4 into this 4 electrons, unpaired electrons are there, 4 into 1/2 plus this will cancel out, that's why we are not mentioning that thing. 4 into 1/2 equal to 2. 2s plus 1 will be 2 into 2 into 1. 2 into 2 plus 1, that is 5. So the S value is 5. Here only one option for only one option with the 5 as 2s plus 1 value. So the answer is D. Now we can check the L value. L means 2 minus 2 into 2 plus minus 1, 0 plus 1 plus 2. Modulus value we will get 2. So L equal to 0 means S, L equal to 1 means P, L equal to 2 means D, L equal to 3 means F. Here L value, modulus of L value is 2, that representing D. So the term is D5. In this option there is no J value, so we don't need to calculate those things. So the correct answer is option D, D5. Next question. Rate of an enzyme catalyzed reaction is 0.02 mole per dm cube, and the rate is halved when the concentration of substrate is 20 mg per dm cube. The ratio of K1 by K inverse will be, assuming K2 is much lesser than K inverse 1. And when the initial rate is halved, that is nu become Vmax by 2, the Michael-Menten constant Km will be equal to the substrate concentration. So Km value will be equal to substrate concentration when the initial rate is halved. So we can write as Km, the Michael-Menten constant, as K inverse 1 plus K2 by K1. That will be equal to the substrate concentration, and that value is 20 mg per dm cube. And it is assumed that K2 is much less than K inverse 1. So we can write or we can eliminate this K2, then we will get Km as our Michael-Menten constant as K inverse by K1, that is equal to 20 mg by dm cube. What we have to find is K1 by K inverse. Just reverse it, 1 by Km. Then K1 by K inverse equal to 1 by 20, that is equal to 0.05 dm cube by mg. So the option D is the correct answer. When the initial reaction rate is halved, Michael-Menten constant equal to substrate concentration. And this equation you have to study. This comes under enzyme catalyst, enzyme catalysis. You have to study the equation. In almost all exams, these equations from questions from these equations are have been seen. Next, Jmax4, a rigid diatomic molecule with a rotational constant 1.566 cm at 300 Kelvin is. Rotational spectroscopy, one video is there. You can check the playlist for playlist like spectroscopy. You can I think I have uploaded rotational, vibrational, IR, NMR, Mosbaer, Raman. In that playlist you can check the videos. Here Jmax have an equation root of Kt by 2 BHC minus 1 by 2. K is the Boltzmann constant, T is the temperature, B is the rotational constant, H is the Planck constant, C is the velocity of light. Just put all the values. This is 10 raised to minus 3. Okay, this is 10 raised to minus 34. While solving this, you will get an answer of 8.1. So option A is the correct answer. Last question in this section. Temperature effect of Schottky defect is given by e raised to e by 2 kt, e raised to minus e by kt, e raised to e by kt, e raised to minus e by 2 kt. Then number of Schottky defect present in the ionic compound containing n ions at a temperature T is given by n equal to capital letter N into e raised to minus e by 2 kt. So our answer is option D. And E is the energy required to create Schottky defect. K is the Boltzmann constant, T is the temperature, and number of Frenkel defect can be n into n dash into e raised to minus e by 2 kt, where n is the number of atom, n dash is the number of interstitial can take up free atom. That interstitial position numbers are n dash. So the temperature effect of Schottky defect is proportional to e raised to minus 2 kt. Also for Frenkel effect, e raised to minus 2 kt. So option D is the correct answer. If you have any doubts in these questions or you have any other answers, you can just comment with the proper reasons. Okay. If you did not watch the first video, I will put one link in the description box, also in the I button. You just watch that one. Remaining question we will do in other parts. If you like this video, like, share and subscribe. You can follow me on Kemagilam Insta and Facebook page, or you can mail me at kemagilam@gmail.com. Thank you for watching.